Hey everyone, and welcome. Today we're going to dive deep into the world of Java concurrency, but we're not just going to list a bunch of dry facts. No, we're going to follow the entire story, the complete journey of a single Java thread, right from the moment it's born to the second it finishes its last job. So let's get started. So here's how we're going to break it all down. We'll start with the big why, what's a thread's purpose anyway? Then we'll trace its life cycle, right from the beginning through all the work and the waiting, all the way to its final moments. And we'll wrap it all up with some really crucial advice on how to manage these threads the smart way. Okay, first things first. Before we get into all the different states and transitions, we've got to answer the most fundamental question of all. Why do we even need threads in the first place? What problem are they solving? Really think about it for a second. You're using an app on your phone, right? It's probably downloading something in the background, but at the same time, the user interface is perfectly smooth as you scroll. How does it do that? How is that even possible? Well, the magic behind that is, you guessed it, threads. Here's the absolute best way to think about this, and it's the analogy we're going to stick with. Imagine your application is a giant factory. Each thread is basically a worker that you've hired to do one specific job. So if you want to get a bunch of different things done at the same time, what do? You hire more workers. It's really that simple. All right, our factory is officially open for business, and it's time to hire our very first worker. This part is all about how a thread gets created and then gears up to actually start its job. So the very moment you create a new thread object in your code, it enters the new state. It exists, we know the paperwork's been filed, but it's not actually doing any work yet. In our factory analogy, we've hired the worker, they're officially on the payroll, but they haven't even shown up for their first shift. And this is a really important two-step dance, right? Just creating the thread with new thread, that's not enough to get things moving. You have to explicitly call the start method. That call is the signal to the Java virtual machine that says, hey, this worker is here and is ready to get on the factory floor. That's what kicks it out of the new state and into the next one. Okay, so once you've called start, the thread is now in the runnable state. Now listen up, because this is a super important distinction. Runnable does not mean running. It just means the thread is ready and waiting in line to run. Our worker has clocked in, they're standing on the factory floor, but they might be waiting for a machine, the CPU, to free up. It's the job of the thread scheduler to look at all the runnable threads and decide who gets to use the machine next. Now we're getting into the real meat and potatoes of a thread's life. This is where all the action happens, where the work actually gets done. But it's also where our little worker might need to take a scheduled break or get stuck waiting for something. When the scheduler finally points to our thread and says, "You're up," it moves from runnable to running. This is the state we've been waiting for. The code inside that thread's run method is now actively executing. Our worker has their hands on the machine and is finally actually doing their job. All right, let's tackle something that trips up a lot of developers. What's the difference between waiting and blocked? Think of it this way. Waiting is voluntary. Our worker decides to take a scheduled coffee break by calling sleep, or maybe they're waiting for a manager's signal by calling wait. They chose to pause. Blocked, on the other hand, is involuntary. Our worker needs a very specific tool, let's call it a synchronized lock, but another worker is already using it. They are literally blocked, stuck, unable to move forward until that tool's put back. And that difference really matters, because while waiting is often part of a design, a lot of blocked threads can signal a serious performance problem. Every shift has to come to an end. After a busy life of running, maybe some waiting, maybe getting blocked a few times, our thread finally gets its job done. So let's take a look at the final chapter of its story. You've got to remember, a thread's entire reason for being, its whole job description, is inside its run method. Once that method finishes, either because it got to the end or maybe an error occurred, the thread has done its duty. And this is a one-way trip. Its job is over and there's no coming back. And that leads us, finally, to the dead state. The moment that run method is finished, the thread is officially considered dead. Our worker has clocked out, they've packed their lunchbox, and they've gone home for the day. And here's the critical takeaway. Just like you can't ask that worker to come back and restart yesterday's shift, you can never call start on a dead thread. If you try, you'll just get an error. Its journey is well and truly over. Okay, so knowing the life cycle is half the battle, but actually managing it, well, that's what separates good, stable code from a buggy mess. So let's talk about some best practices for keeping your threads and your application healthy. I want you to look at this slide and see a big flashing red light. You might be tempted to find a method to just stop a thread in its tracks. But the stop method has been deprecated for a very, very good reason. It is incredibly dangerous. It's like firing our worker in the middle of a delicate task without letting them clean up. It can leave your whole factory, your whole application in a broken, inconsistent state. It's just not safe. Avoid it at all costs. So what's the right way to do things? Well, it really boils down to a few key ideas. First, use synchronization properly to avoid deadlocks. That's the nightmare scenario where two of your workers are stuck in a standoff, each waiting for a tool the other one has. Second, make sure your threads can communicate safely, maybe using things like wait and notify to coordinate. And most importantly, always design your threads so they can finish their own run method naturally. A clean, graceful exit is always, always better than pulling the plug. And there you have it. Let's do a super quick flyby of the whole journey. It starts as new, then start gets called and it becomes runnable. The scheduler picks it and it's running. It might pause to become waiting or blocked, but it always comes back to runnable. And finally, when the run method is all done, it enters the dead state for good. So we've followed a thread from the cradle to the grave, so to speak. The next time you type new thread, you'll know you're not just making an object, you're kicking off a whole journey for a brand new worker. So the real question is, how will you make sure that journey is a smooth and productive one in your own code? Thanks so much for joining me.